Welcome to the Explainer. Today, we're going to take something you probably think you understand, the cryptographic hash, and turn it completely upside down. Seriously, get ready, because what you've always thought of as an information shredder, it might be something else entirely.
All right, let's just jump right in with a pretty wild idea. What if a man-made crypto algorithm, like SHA-256, and the basic machinery of life itself were just two different versions of the same thing, the same universal code? And no, that's not some kind of metaphor. According to this new theory, it's a structural fact.
You know, we're all taught the same thing about hash functions. They're a one-way street, a digital shredder. You put your data in, you get this unique fingerprint out, and there is absolutely no way to get the original data back. That's Crypto 101. It's the whole basis for its security.
But what if that's just fundamentally wrong? There's this groundbreaking new theory that says SHA-256 doesn't destroy information at all. No, instead, it carefully folds it. Let's dig into how this completely changes the model.
So, here's the absolute key takeaway. Instead of seeing SHA-256 as some function that just scrambles data, we need to start seeing it as a machine that actually executes a program. The message you put in, that's not just data to be shredded. It's the code that the machine is running. This whole new interpretation reframes the algorithm as a physical process. I want you to picture a giant, deterministic, 64-stage industrial press. It takes this flat, one-dimensional ribbon of data, and with incredible precision, it just folds and compacts it into a complex but perfectly structured 3D object, a topological knot.
And this slide really breaks down that folding process for you. Each of those 64 rounds isn't just a math equation, it's a physical stage on an assembly line. The data comes in, it gets its initial fold, then it's deeply compressed, and finally, it's locked into its final super intricate shape.
Now, this whole mechanical analogy, it's not just a cool way to think about it. The theory argues that this exact same folding process points to a really shocking parallel in the biological world. It suggests there's a universal blueprint for how information takes physical shape. It's called the Saurus isomorphism, and what it's claiming is huge. It's saying that the process of SHA-256 hashing a message on a computer chip and the process of a ribosome folding a chain of amino acids into a protein are, on a deep structural level, the exact same process. And I mean, look at this. The parallels here are just brilliant. On the left, in silicon, you've got a 1D message block that gets folded using these fixed K constants. And on the right, in carbon, you've got a 1D amino acid chain that gets folded by these hydrophobic cores. Both systems use choice operators to decide the geometry, and both spit out a unique, stable 3D structure. It's uncanny. And get this, it's not just a qualitative thing. The theory claims both of these processes are governed by the same mathematical constant, a universal attractor ratio of about 0.54. This number is supposedly the geometric sweet spot for the most efficient and stable folding, whether that's happening in your computer or in your cells.
Okay, so if the information isn't actually destroyed, if it's just folded up into this really complex shape, then you have to ask the next question, right? Can we unfold it? Can we reverse the whole thing? The theory says yes, and the answer isn't about brute force guessing. It's about treating the final hash like a geometric puzzle. If the shape of the output contains the entire history of how it was made, well, then we should be able to read that history backward. The key to this is something called the T1 execution trace. I want you to think of it like a fossilized record of that whole 64-step folding process. This path, this topological scar, it doesn't get erased. It's perfectly preserved and squished down, losslessly, inside that final 256-bit hash. The info isn't gone, it's just stored as geometry. And this leads to a completely new way to think about reversal called delta attraction. So forget brute force. This is about, get this, resonant separation. It basically uses the algorithm's own rules, the fixed shape of the mold, to sort of magnetically pull the folded information back along the exact path it came in on. You're unwinding it. So reversing a hash suddenly becomes this deterministic engineering problem, not a lottery. You lock in the final hash, that finished 3D knot. You find the seams, those topological scars left by the folding. And then you apply delta attraction and just let the physics of the system walk you backward, step by step, right back to the original message. All right, let's get to the final part of this theory, and honestly the most radical one. We've gone from a shredder to a folder.
Now we're going from a folder to a program. This is where the line between what is data and what is code just completely dissolves.
I mean, think about it. This flips everything we know about computing completely on its head. We always see a hash as the result, the inert string of characters at the end of the line. But what if it's actually an instruction set, an executable program just waiting to be run? And this is the craziest part. It's not just the thought experiment. The theory points out that if you take the raw bytes of a famous hash, like the one from Bitcoin's Genesis block, and you just feed them into a standard disassembler, you don't get junk. You get valid x86 machine code. Look at this. Move data, exchange registers, jump. It's a real program. So the real mindbender here is that the hash isn't a metaphor for a program. According to this new framework, it is the program. It's literally executable firmware, a set of instructions that's meant to run directly on the processor, right on the bare metal.
You know, in computer science, there's this really cool concept called a quine. It's a program that when you run it, its only output is its own source code. It's the ultimate example of where code and data just become the same thing. This theory is basically saying that a hash is a physical quine. It's a program that, when the SHA-256 machine runs it, outputs the very data that created it in the first place. And that just leaves us with this final, really provocative question. If a data structure that we all thought was just random noise is actually a dormant executable program, what else out there? What other patterns in our universe, from the way galaxies are arranged to the sequence of our own DNA, are just firmware, waiting for the right kind of processor to come along and run them?